The James Webb Space Telescope has uncovered something truly remarkable: beams of light that appear to radiate from an urban center shining from a location light years away. This discovery has sparked renewed interest in the potential existence of extraterrestrial life. The telescope directed its focus toward Proxima Centauri b, the nearest exoplanet to our solar system, and noticed strange, brilliant flashes of light. Could these signals be signs of an alien civilization? Stay tuned for more developments. For years, both scientists and everyday people have been fascinated with the concept of life beyond Earth. Any evidence hinting at the presence of life in outer space has been met with great enthusiasm. But a pivotal moment came when the James Webb Space Telescope presented clear evidence suggesting the existence of life somewhere in the cosmos. While scanning the depths of space, this powerful telescope discovered something extraordinary on an exoplanet located far away. It detected lights that resembled those from extraterrestrial cities, igniting the possibility that an alien metropolis might exist on that distant planet. This idea has generated significant excitement and curiosity within the scientific community, as it could be the breakthrough they have long anticipated. It hints at the presence of intelligent beings operating civilizations in ways we are only beginning to explore. Looking at these city-like lights from a remarkable distance of 4 light-years away, NASA engineers are astonished and wonder just how long they might have been visible in space, waiting for our technology to advance to the point where we could detect them. David Kipping, an astronomer at Columbia University, has described the planet where these lights were discovered as particularly intricate. Unlike most rocky planets that absorb sunlight and emit energy as infrared radiation, this exoplanet behaves differently due to its unique relationship with its host star, Proxima Centauri. This discovery made by the James Webb Space Telescope underscores the telescope's critical role. Its ability to capture infrared wavelengths was essential in identifying the unusual behavior of Proxima Centauri b, which is crucial for understanding the planet's atmospheric conditions. Researchers are planning to continue using the telescope to study the atmosphere of this planet in more detail, with hopes of investigating whether it might be habitable. The James Webb Space Telescope is particularly sensitive to infrared light, enabling it to observe what happens on Proxima Centauri b even during the night. Many telescopes struggle to detect faint light in the vast darkness of space, but the Webb telescope excels at picking up even the faintest glimmers. This makes it an ideal tool to confirm if the alleged city lights on the dark side of Proxima b are indeed real. The telescope can detect artificial light in space, provided it falls within a very specific frequency range, much narrower than the light emitted by regular stars. Proxima Centauri b has a dynamic interaction with its star, which heavily influences its environment. Like many planets that orbit stars, it captures intense energy from Proxima Centauri. As the planet revolves around the star, it goes through cycles of day and night. Much like Earth, the planet experiences scorching heat during the day and cooler temperatures at night. The range of temperatures on Proxima Centauri b is vast, primarily due to its composition. For instance, if the planet had an atmosphere, the daytime temperature would be extremely different from nighttime, with hotter temperatures on one side and colder temperatures on the other. This dramatic thermal fluctuation is a key area of interest for astronomers, as it provides valuable clues about Proxima Centauri b's atmospheric makeup. The James Webb Space Telescope, with its ability to image in the infrared spectrum, can effectively examine the planet's thermal emissions, offering insights into its atmospheric properties. Interestingly, the orbit of the James Webb Space Telescope around Earth coincides with the orbital period of Proxima Centauri b, enabling scientists to make detailed observations of its daylight cycles every 11.2 Earth days. If Proxima Centauri b has an atmosphere, the next step will be to analyze its chemical composition to determine if it could support life. Detecting elements like oxygen, water vapor, and methane would suggest the planet's potential to harbor life. This would involve studying the light passing through the planet's atmosphere, a complex process. While the James Webb Space Telescope is excellent for characterizing planetary atmospheres, it is primarily designed for other tasks. Its expertise lies in analyzing the concentrations of water vapor, carbon dioxide, and methane, but it is less adept at detecting free oxygen, a crucial sign of life. Nonetheless, the telescope can search for other key indicators like ozone, which signals a healthy atmosphere. As scientists examine the data gathered from the James Webb Space Telescope, the hunt for distant worlds continues. The search is bringing us ever closer to answering the question of whether we are alone in the universe. It's important to note that the James Webb Space Telescope can only observe a limited number of exoplanets closest to Earth. For more detailed studies of planetary atmospheres, astronomers will rely on ground-based observatories like the Extremely Large Telescope, ELT, which is set to begin operations in 2027. The ELT is designed to offer a deeper look at the atmospheric structures of far-off exoplanets, providing clearer and more detailed data on their potential to support life. Scientists are eagerly awaiting the launch of future space telescopes like the ELT. In the meantime, the James Webb Space Telescope remains an invaluable tool for exploring distant exoplanets. The Webb telescope continues to provide crucial information that may alter our understanding of what exists beyond our solar system. Despite its limitations, researchers have ambitious plans for future space telescopes. They aim to develop technologies that reduce starlight interference, allowing for better observation of the planets around them. Similar to using your hand to block the sun in order to see more clearly, these upcoming telescopes will be able to focus on the faint light reflected by exoplanets, making it easier to analyze their atmospheres and assess whether they might be capable of supporting life. However, this task is far from simple. Stars are incredibly bright, often vastly outshining their surrounding planets. This brightness makes it difficult to detect the faint light that planets reflect, which is essential for studying their characteristics. To address this challenge, scientists are working on several innovative techniques. One such method involves the use of coronagraphs. These devices are placed inside telescopes to block out starlight while letting the light from the planet pass through. By carefully shaping the light waves, coronagraphs can significantly reduce the brightness from the star, making it easier to detect the dim light from exoplanets. Another promising approach is the star shade, a massive flower-shaped spacecraft that will fly in formation with a telescope positioned tens of thousands of kilometers away. The star shade blocks starlight before it even enters the telescope, allowing only the light from exoplanets to reach the instruments. This technique could be particularly effective in observing planets within the habitable zone of their stars, where liquid water and possibly life could exist. However, these advanced technologies require extraordinary precision. For instance, the alignment of a star shade must be perfect to fractions of a millimeter over vast distances. Moreover, these innovations must overcome the limitations posed by space missions, including the need for miniaturization, energy efficiency, and the ability to withstand the harsh conditions of space. Despite these obstacles, the potential rewards are enormous. Successfully observing and analyzing the atmospheres of exoplanets could lead to the discovery of biosignatures, chemical indicators of life such as oxygen, methane, or water vapor in specific ratios. These molecules might point to biological processes, suggesting that life exists beyond Earth. Researchers are also exploring ways to directly image distant worlds in greater detail. Future telescopes could be equipped with advanced adaptive optics, which adjust for distortions caused by Earth's atmosphere or the telescope's movements, resulting in sharper images. Combined with starlight blocking technologies, these improvements could allow scientists not only to detect exoplanets, but also to map their surfaces and study their climates. The development of next-generation space telescopes represents a significant leap forward in our quest to answer one of humanity's most profound questions: are we alone in the universe? We are getting closer to finding out if life exists beyond Earth by improving our ability to observe these faraway planets. This could change how we see our place in the universe. The future of space exploration and the search for life beyond Earth is advancing at an unprecedented pace. As scientists and astronomers dive deeper into the mysteries of distant exoplanets, The James Webb Space Telescope is opening a new era of cosmic discovery. The data it gathers is helping astronomers make groundbreaking revelations about the structure, composition, and potential habitability of far-off worlds. With each new piece of information, we edge closer to the ultimate question: is there life beyond our planet? Proxima Centauri B's discovery is just the beginning of what could become a major turning point in how we approach the study of extraterrestrial life. Proxima Centauri b, being the closest star to our own solar system, has been a focus of intense research for years. However, until now, finding concrete evidence of life, such as artificial light or signs of civilization, was a dream for many scientists. The fact that such light has been detected by the Webb telescope only enhances the hope that one day we may contact other intelligent life forms in the universe. This kind of discovery fuels both scientific curiosity and public imagination, inspiring new generations to think beyond the confines of Earth. As the James Webb Space Telescope continues its observations, it's not only looking for artificial lights, but also focusing on planetary atmospheres, their chemical compositions, and how these factors could support life. The search for biosignatures like methane or carbon dioxide in the right concentrations is vital for understanding whether these planets have the right conditions for life. The Webb telescope has the ability to look at these atmospheric components in a way no other telescope has been able to, shedding light on the potential of distant worlds to support life similar to Earth. One of the most fascinating aspects of Proxima Centauri b is its location within the habitable zone of its star, where conditions might be right for liquid water to exist on its surface. The habitable zone is the region around a star where temperatures are just right, not too hot and not too cold, for liquid water to form. This is considered a critical factor in determining whether a planet could harbor life. Water is essential for life as we know it, making the